Hey guys, Ketlin back here. Lesson 2 for your homework this week. Let's jump in. Number 1, the likelihood that Han makes a free throw in basketball is 60%. The likelihood that he makes a 3-point shot is 345 thousandths. Which event is more likely, Han making a free throw or making a 3-point shot? Explain your reasoning. Okay, well, generally people are better free throw shooters than 3-point shooters. That could be part of your reasoning. But I'm going to say that he's going to make a free throw more often. Okay, so free throw is going to be my answer here. It's a shorter shot. You're more likely to make it anyway. All right, but there's mathematical reasoning here as well. Okay, 60% is greater than 0.345. Now, here's why. Because 60% is the same as 2 decimal moves to the left, this, and that's greater than 3, 4, 5. And you might, wait a minute, that's got more digits. Well, imagine that is 600 versus 345, clearly bigger. Another way you can think about this is if you change them both to percentages. 60% is bigger than the percent version of this. If you move it over twice, that would be 34.5%. Okay. Either way you look at it, free throw, better opportunity of making it versus the other. Explaining our reasoning, I think if we show something along these lines, you could also say something like 60% is more than likely. It's likely to happen. And or is likely to happen, and a 3-point shot is unlikely. You could say something like that. Lots of options there. Number 2, different events have the following likelihoods. Sort them from least to greatest. In order to sort things from least to greatest that are not in the same form, it's best to choose your favorite format and put them all that way, and then order them. So my favorite format is percentages, and also because 2 of them are in percent form. So I feel like that's going to be the less amount of work for me. So I don't have to do anything with 60%. I can leave it the same. I don't have to do anything with 20%. I can leave it the same. But I need to change 8 out of 10, which is this as a fraction, into a percentage. Okay, and that's pretty easy. 8 out of 10 is the same as what? As a per 100. It's 10 times bigger, so this is the same as 80% for this one, which I already know is bigger than 60. The next one, 37 hundredths, that's an easy change to a percentage because it's 2 decimal moves to the right. It's 37%. And then the following one, 20%, don't have to change anything there. It's already in percent form. This is one that we struggled with without a calculator. Take the top number and divide by the denominator, and it will convert it to a decimal in which you can change to a percentage. So obviously it's proper. 6 won't go into 5. It will be 0 point something. It will be less than 1. 6 will go into 50 8 times because 8 times 6 is 48. Difference of 2. Drop down our zeros 3 times. And we'll start to notice that 2 repeats when we drop it down. So it'll be 20 over and over again. And 6 will go into that 3 times over and over and over again. So this one is actually equal to 0.833333 repeating, which when you move the decimal 2 places to the right and convert it to our percentage is 83.3%. Now we can order from, what does it say, least to greatest. Okay, so our least, 60, 80, 37, 20. So the least is 20%, followed by the next least looks like to be the 37, so 0.37. And then the next least looks to be from this group, the 60%. And then followed by 80%, which was 8 out of 10. And then the biggest was 5 out of 6. So there's our order of likelihood from least to greatest. Number 3, there are 25 prime numbers between 1 and 100. And there are 46 prime numbers between 1 and 200. Which situation is more likely? Explain your reasoning. A computer produces a random number between 1 and 100 that is prime. Well, since there's 25 there, that would be 25 out of the 100, which your odds of that happening, well, obviously are 25%. Okay, so let's look at the next one. A computer produces a random number between 1 and 200 that's prime. Well, there's only 46 out of 200 that are prime between 1 and 200. So that's the same as 23 out of 100, which is only 23%. And even though they're super close, I'm slightly going to go with A here because 25% is a little bit better odds than 23%. All right, and number 4, it takes 4 3/8 cups of cheese. 4 3/8 cups of cheese, 7/8 cups of olives, and 2 5/8 cups of sausage to make our signature 1 pizza. How much of each ingredient is needed to make 10 pizzas? Okay, so we need to make everything grow by a constant of times 10 to make everything much, much, much larger. So in order to do that, you can use your calculator, obviously, but I'm going to do this without a calculator because why not? So I'm going to do 4 3/8, which is the same as 4 times 8, 32 plus 3, 35 eighths. We're going to multiply it by 10. So that would be 350 over 8. So this would be 358 cup of cheese. 7/8 times 10 over 1 would be 78. So 78. And then 2 5/8 would be the same as 16 plus 5, which is 21/8 times 10. Be 210 over 8 cups of sausage. Now, obviously, you could change those back into improper fraction or mixed numbers, but I'm just going to leave them that way for time purposes. If you guys want to do that, you can just divide them, and your remainder is your new numerator. And there you go. That's a lot of cheese, a lot of olives, and a lot of sausage, but you are getting 10 times more of everything. See ya.